Everyone, my name is Payal Fulsagar. So today we will learn about NPDA, that is means non-deterministic push-down automata. In short, it will be called as NPDA. A non-deterministic push-down automata is an abstract computational model widely discussed in the theory of computation talk that extends the capabilities of finite automata by incorporating a stack and non-determinism. An NPDA can recognize a broader class of languages, specifically all context-free languages, including some languages that deterministic push-down automata cannot accept. So further, we will see what is the NPDA formal definition. So NPDA is formally defined as a tuple which contains these symbols. So first, the Q stands for finite set of states. Summation, or it can be also known as input alphabets. So this will it will be referred as stack. Then the delta function, which can be used for transition function, and for this NPDA transition function will be del is equals to q into summation of union of null into, so it will give the values allowing multiple possible transitions for each input and stack situation. Then as all normal q0, which will the start state, z0, it will the initial stack top symbol, and finally f will be the set of final accepting states. So these all symbols, or we can say all parts contain plays very crucial role. So further we will be seeing like how the NPDA actually work. So NPDA begins in the initial state with only the initial stack symbol on its stack. It reads the input symbol at a time, considering both the current input and the stack stop symbol. The transition function returns a set of possible moves, and the NPDA may non-deterministically choose any of these transitions to proceed. At each step, the NPDA can push symbols onto the stack, pop symbols from the stack, or leave the stack unchanged. Then, further, the acceptance occurs if at least one sequence of transitions from the initial to the final state, reading to the whole input, ends with an empty stack or in an accepting state, depending on the acceptance criteria. So thus the NPDA, that is non-deterministic push down automata, works. So further we will see the example of language, like how NPDA will work on a simple language. So consider the language L. So it will be followed by W raised to R, such that W belongs to summation star. So where W is raised to R is the reverse of a string W. So NPDA can split the input non-deterministically, push the first half of the input onto the stack, and they start popping symbols off of the stack, so matching them with the second half. If the stack becomes empty and the input is fully read, the NPDA will accept the strings. Next is a very important part, that is nothing but the difference between NPDA versus PDA. That is the difference between non-deterministic push-down automata versus deterministic push-down automata. So here we will determine this difference based on these features, which will contain determinism, transition function, and recognition power. Continuing with the first difference, so in case of NPDA, determinism leads to multiple possible transition per step, whereas for DPDA, single unique transition is needed. For the second point, here is a transition function. In NPDA, the transition function will return a set of moves, while for DPDA, it will return only one move. In recognition power, all context-free languages, and some of them will be ambiguous one for NPDA. But when it comes to DPDA, the subset of context-free languages will be also there. So this is the main difference of NPDA and DPDA. Thank you.